Hi, this is Group 37 presenting our project management plan on waterless fracturing. The first person speaking will be Josh Brunet. Currently, hydraulic fracturing uses hundreds of thousands of barrels of fresh water with the addition of chemicals to break rock formations and create artificial pathways for fluids to flow into the wellbore. While this has proven to be successful, it does have environmental concerns. There are some concerns that hydraulic fracturing is polluting freshwater aquifers. Certain areas of America are in extreme drought and cannot afford to possibly have their aquifers polluted or to use that much water. According to Ceres, a nonprofit organization that focuses on water scarcity, 41% of wells in the U.S. are in regions with extreme water stress, or in areas where more than 80% of available water is being drawn by municipal, agricultural, and industrial users. New York has already banned the use of hydraulic fracturing altogether. In order to still fracture the formation without the use of water, the industry had to find an alternative. The alternative they came up with was gas fracturing. Because of this, we decided that we wanted to compare the effectiveness of hydraulic fracturing to gas fracturing. We also want to prove that if the right infrastructure is in place, then propane fracturing will be a major cost saver and could be used to help aid in all the environmental concerns. In order to perform these tests, we will construct a reservoir model and try to simulate the fracturing techniques of hydraulic fracturing and waterless fracturing such as liquefied propane gas and CO2. After we've completed all of our tests, we hope to have data regarding fracture pressures, lengths, and amount of fluid used to fracture the simulated reservoir. We also hope to have the videos of us performing these tests. Our team consists of 3 members, which includes Travis Stevenson, Josh Brunet, and Marshall Druick. Dr. Williams will be our program manager. We will be providing him with frequent updates on the status of our project. He will be the person that will have the most power and will be the one that grades our results at the end of the time period. We will also be relying on the help of the PERT lab facility members to acquire the necessary materials to assemble the reservoir model. All decisions will be made as a group, and the final decision will not be made until after all members have come to an agreement. We will construct a model with compacted sand that we will fracture with different fluids and gases. The compacted sand will simulate a sand reservoir. A PVC rod with perforations in the middle will be placed in the center of the model to simulate a cased well borehole. This rod will be connected to a line which will be connected to a pump. The pump will be connected to a tank of water, propane, or other gas. This will simulate fracturing done in the field. After performing each test by pumping individual fluids or gas into the reservoir model, data will be recorded in regards to flow rates, pressures, fracture lengths, and the amount of fracture fluid used. After running all of these tests, we perform a cost analysis of each fracture fluid used. After having a lab analysis of each fluid and a cost analysis, we will be able to fully analyze the efficiency of waterless fracturing compared to traditional hydraulic fracturing.
Hi, I'm Travis Stevenson. I'll now be talking about our milestone list. This graph shows our milestone list for the essential events that need to be completed and when we plan on completing them. This timeline shows the steps of when each major component of this project was completed for this semester. This timeline shows the major steps of when each component will be completed in the next phase of the project. The management system will have 5 parts: initiation, planning, execution, control, and closeout. Initiation will consist of the evaluation and recommendations of projects, development of the charter, and submitting of the charter. Planning will consist of creating a preliminary scope, determination of project team, project kickoff meeting, the development of a project plan, submitting the project plan, and the milestone. Execution of the project will consist of the kickoff meeting, verification of user requirements, designing of the system, hardware procurement, testing phase of the experiment, installing the live system for tests, user training of the system built, and finally going live with the experiment. In control, the project management is created along with the project status meeting and the updating of the project management plan. The closeout will include the audit of the project, evaluation of the data attained, updating of all files, and gaining formal acceptance. Though we do not plan to make any changes after this date, a plan must be in place if a change is necessary. For a change to be made, a team member must present to the team his new idea and why he believes a change will be beneficial to the project. Next, all team members must approve the change. Then, we must inform the rest of our stockholders of the possible changes and see if they also approve of it. Next, we will implement the change in the smoothest way possible so that we do not get too far off our planned schedule. And finally, we plan on monitoring the change and decide if we made a good decision in the change. Shown here is how we plan to communicate and the methods of how this communication will take place throughout this project. These are some rough estimates and are subject to change. Marshall Druick, the project manager, will be responsible for managing the costs. Each group member has an input on the changes to the project and budget. A record will be kept after every purchase and managed on an Excel sheet. All costs will be presented to every stockholder. The major deliverables for this project are the fracture pressures, lengths, and amount of fluids. In order to have quality results, we plan on running multiple tests with each liquid. For each test, we will change the pressure and flow rate to get multiple results. This will ensure that we will get quality results. For each test, we will analyze how the change in pressure or flow rate affects how effective the fluid was in fracturing the formation. This will give us comparable results for all liquids, which will let us come up with a conclusion at the end of the semester as to which fluid is the best fluid for fracturing formations.
The risk of performing this experiment on propane fracturing is that propane fracturing can be much more dangerous due to it being highly flammable and explosive. Because of this, extra care needs to be taken when dealing with propane. Any open flame must be avoided. Another risk is that gas fracturing could not be as effective at opening up tight formations as traditional hydraulic fracturing. This is a performance risk that needs to be considered. If the propane does not perform as well as the traditional hydraulic fracturing, time and money will be wasted. Another risk is that after doing a cost analysis of gas fracturing could be a lot more expensive than we anticipated. As of now, we have a rough idea on the cost of performing this experiment and analysis, but unforeseen circumstances could cause us to spend more money than we currently plan on. The final risk is that we will not be able to perform this experiment or will not be able to get all the data needed. As of now, we do not know if the acrylic sheets will be able to withstand the pressure of water or the gas. Also, with the time constraint, we may run out of time and not be able to get enough data to come to an adequate conclusion. The resources that need to be acquired are listed below. Our group has 3 members that will each have a specific role in the completion of this project and is responsible for gathering the necessary equipment. We think that this will make it easier because a lot of equipment will come from different places. The majority of the materials will have to come from the PERT lab, such as the pressure gauges, flow meter, and possibly the pump. The rest of the materials, such as the acrylic sheets, epoxy, sand, and PVC pipe, will have to be acquired in other locations, such as Home Depot. Each member has the same role in the project, which includes the actual construction of the model and in performing of the experiment. Each member will record certain data during the experiment. At the end, will all combine in order to determine the outcome of the project. This slide shows when we will need to acquire each of the components and how long we will need to be in possession of them. In this project, we hope to obtain quality results in our experiments. For our project, it will be easy to determine if quality standards have been met based on the results gathered by the flow meter, amount of fluid used, and pressure gauges. The major quality standard for our project will be based on how each fluid will fracture the sand formation we create in the model. All fluids must be able to create fractures in the sand, and one fluid must be better than the rest at doing so. If the fluids cannot fracture the sand or the best fluid for doing so cannot be determined, there will be no quality data for the desired outcome of this